Welcome again to part 3 of this crash course, and I will say you've really done well if you are still with us to this third class of it. Now it's a wonderful progress, and by now you've learned all the basic principles in that. You've learned the data types, you've learned the variable declaration. You've also learned what it is to declare a function, the different types of function manipulation, higher order functions. You've also learned conditional statements and while loop. And I think we've learned a lot of things, a lot. So by this time now, we are now moving towards the final aspects of that as a language before we now go into the framework. Remember, I said Flutter, it's built on top of that, which is Flutter is the framework for front end. Why? Dart Frog is a framework for back end, and that is the language itself. That both of these frameworks are using. So we are going to be going into what OOP means now. So OOP, from the word object oriented programming, it's actually a programming paradigm based on the concept of objects. So we are talking about OOP, object oriented. Yes, it's about objects. And what is objects? Object is an instance of a class. So when you create a class and you initialize the class, you give an instance of the class. That instance of that class is what we call an object. That is a true object-oriented programming language, meaning everything in that is an object. Take it. Everything in that is an object, even to numbers, function, no itself. Remember when we were talking about no the other time? No is like an empty construct, an empty container that there is nothing inside. So when you say something is no, it means there's nothing inside. No itself is even an object. So that itself it's an object-oriented programming language. Everything is an object. So now let's move. What are the core concepts in the concept of OOP in that we are going to be looking at today? We are going to be looking at classes and objects. So as we said the other time, that a class is a blueprint for creating an object, where an object is an instance of a class. So when we say a class, basically a class is like a definition of when you are defining how an object is supposed to be. For example now, okay, let's go to our dashboard. Let's create a new sample template. So now let me create a class and let me call it an animal class, which is called an animal. Now automatically when I say I create a class, it's like an entity. Creating an entity, that's what a class simply means. And in that, when you want to create class, it starts with small letter class C as the class. So this is a keyword in that. Class animal. Immediately I create this, I've created an entity. So now let me initialize it. Then we can have, so now for every class there is always for every animal there is always a name. Do you get? So there is always a name, and that name, let me just make it optional now so that's not throw an error before we now go to the explanation of each concept in it. Can you see? So now it's optional, it's not necessary. Just like every human being, as they come to the world, they don't have a name by default, to give them the name later. So now every animal we have a name. So now let's just create an instance of this animal. We can say goats. Do you get that? Now, when I put animal as a type, automatically I've made this thing, I've given it a type of this class. The data type now is of this class. Remember, we said it the other time when we were discussing here that numbers, even string, it's a type of class in that. So because you said string name here, that's this string you're looking at is a class, and you are declaring the type already. The same thing that happens here, animal, goods. These goods, it's already a type of animal, and you've declared the type already. So we can either say var goods is equals to an animal. So that is what class is. Class is just like creating an object. It's like creating an entity, whereas and it's the blueprints on which objects are created. So now when you now want to create an object itself, that is when you now instantiate a class, and that is where an object comes in. So while we do that, let's continue. So now a quick one. So let's talk about constructors. Now, for every class, there is always a constructor, which is very important. It's not necessary that you have to write the constructor. There are default constructors that come in sometimes. For example, let me just give us the first one now. So this is a default constructor. So for example, animal, a default constructor is you just create an instance of the animal and then initialize this an animal automatically, and with this it's going to allow me to set now. Yeah, so with this, it means immediately you create the constructor, you need to define whatever it is that it is called. Do you get? So now, for example, let me move forward in defining a constructor, a class of animal info. Now we've said an animal, we've defined the name, and we've made it optional, right? But now let's make it required. It's no longer optional. Write down is going on. So now it's no longer optional because we want our animal to have a name anytime they are declaring the animal. Do you get? So now, and then we know that there is something that is common with every animal. What is it? The make sound. So let's create a function. Function make sound. So now, and remember our function now. I want it to take a type of string. So we print making sound. So automatically making sound what? So now that we've declared a constructor, and this is a default constructor, is a way you declare the default constructor. You declare the variable here, and then you put it here. So now another thing about constructor is parameterized constructor. Now, what do we mean by parameterized constructor? It's a scenario in which you want to be able to set, okay, this is what we want, and you want to be able to know which one is required, which one is not required. And whenever you are declaring it, just like the way we did in function, if you remember, there's a type of function that you have to declare it in arrange order, like this one now. Okay, you said name. Another thing, let's just use another thing. What other thing that you think is common to all animals? We give them the name. Another thing that is common to an animal is just like every age. So age should be number, right? Num. Okay. Now remember age. Sorry. So remember that the other time when you want to declare oh yes, so remember that in the other time when you want to declare, you need to declare in such a way that you have to just pass the value in which they represent in it. So now let's see if you don't pass this value. Now you have to pass string, and then the number will be 24. Yeah, I've initialized age. So you see that a number must be passed. Now in this scenario here, you will notice that I need to pass it just after each other. I cannot do like this. It will give me an error, just like the way we did in function. So now if you want to be able to set the value, you can pass it anytime. That's where you have to parameterize it. And how do we parameterize? It's just to put, just like the way we did in the other one. Now if it's required, you make it required, and then required. So this is basically it. Now when you are now giving an instance of it, you create an instance and now say name, or let me just start with age so I know that I cannot scatter it. Age is 24 and name is goat. So I don't know, I've not seen a 24-year-old goat before though. So automatically, what do you see that happen there? We've created an instance, and then we've given it a parameterized function. So now let's move. Now we have the last type of constructor, which is a named constructor. Sometimes you want multiple ways of you creating an object. You can define a name constructor to handle that. It's a very rare use case scenario actually, but it's something that you can still do if you want to. For example, let me give you let's say for this animal now. For this animal, you want something like a good animal and a bad animal. So and you want to you've created a constructor for it already. The first constructor, the name constructor. Now we now want to do a name constructor that you can use. Let's say we have an animal here. I can now say animal dot bad. So yeah, you also have. So you see. So this animal dot bad, and then we can say animal dot good. So this is a type of name constructor where you can set the type of, if you want different things. So with that, you can set what you want it to happen immediately that is called. So that's a type of constructor that you've set here immediately. You've created that function, and if you like, you can even make it a function. You can make it a function instantly. With that, once it is picked and once it's cleared, the function is called immediately. The function is called immediately. So that is basically with named constructor. So it's a rare scenario which you might also use a lot. So now the concept of OOP, we are picking this one after the other now. Inheritance is like a class, just like as we have, you are a father. If you're a man, you are a father. If you're a woman, you are a mother, right? You have a child. The child inherits things from the parents, right? Traits, behavior, character, all those things are inherited from the parents. So the same thing applies also here. Now, there can be a parent class and there can be a child class. Now, the child class will inherit from the parents. In other programming languages, a class can inherit from two or more classes, one or two or more classes. But in that, we only support single inheritance. That is, sorry, I can say you can only have a father, you cannot have a mother, or you have a mother, you cannot have a father. That's what it simply means in that. But in other programming language, you can have father, mother, and you can have stepmom, stepdad. You can have all the four of them together. But in that, we only support single inheritance, and I'm going to show us how inheritance work in that. So inheritance is achieved with the use of the keyword extends. The keyword extends. Now remember that we have an animal, right? A class that is an animal. So now let's create another class. Oh, we've removed our constructor, which we are not supposed to do. I just want to remove the named constructor. So now we already have what? An animal, right? Now let's create another class. We call it a dog, and it extends animal. Do you get? Now because an animal has constructor, so also your dog needs to also have a constructor. So because we already have this name and age coming already from the animal class, remember I said that once you extend a class, you already have every trait inside that class. Everything inside that class belongs to the child class automatically. So the same thing also here. And because we already have the animal class coming from here, we just need to, what is special thing that are common to dog? We can say they have their own breed, right? They have their own breed. Once you inherit from the parent class, you automatically have all the features of that parent class. So now let's try to create a constructor for this. Now what is special about dog? Dog has breed, right? So now let's pick something from there. Dog has breed, and then let's create a constructor for this one. Now required is string of type name. Yeah, because it's coming from the parent class, it's going to be, that one is coming from the parent class. So required string of type age, then finally required this dots of type breed. Now you notice I use this is talking about this class itself, so that's why I'm able to pick it. But you see this one, where is it coming from? So I need to tell you where it's coming from, which is this super, from the super class. So from the super class we have name as name, the name as name, comma, and age as age. So that's, so we have the age as age. Is it not age? Yes, it's age. So it's not supposed to be string. Yeah, so you see there's a mistake here. This age is coming as num, but yeah, I'm setting that string, which is not supposed to be, so it's going to have to be num, so that it can be free. Exactly. Great. So now a dog already extends all the features in the animal. Now when you create a dog, you automatically has a name, age, and it has breed. So now that's not all about it. There's another thing we can do here with this class extension, is to override what all animal can do. See, all animal make sounds, right? So the function there, we can override it. Let's assume that you want to create a custom sound. Now you can now say print dogs make this sound. So before, if I didn't overwrite this and I just call that function, I'm going to show you before then. Now let's see. Let me clear out this one and let's declare var my dog is equals to a dog. So I have the name of my dog. I call my dog Prado. Now the age is just 2 years old, and then the breed, I don't really know much about dog. Don't mind me, I don't really know much about dog. So the breed, I can just call it local. Like they use local dog. All right, so it's a local, that's my breed. So now automatically I can say my dog dots make sound. Now the sound type is back. How do you spell boo boo? So this is the sound that my dog makes. Now let's run it. You see what will happen automatically. It's going to print out making sound. So now it makes this sound automatically without me setting. Do you see that I didn't here in this? There's no function here that represents make sound, but because it's coming from the master class, automatically inherit all the features there. So this is very important, because when you're writing your code, you might need to create a parent class, and which all class might some classes might have to inherit from. So quick one, we are taking a lot of time already. You understand where this is, and if you want to overwrite, I just want to show you this. If you want to overwrite, now let's run it again. You will see what will happen. It's going to give us a different thing. It's calling the 2 already. It's calling dog makes sound, making sound, and the reason is because this super is still being called. So if the super is not called again, it's not going to, it's just going to return dog makes this sound. But once you still call this super, here is going to run that action, and it's still going to run this one. And you will see in stateful widgets, especially in Flutter, you will see scenarios like this where you overwrite the init states. So you still have to call super dot init, or else the initial states in this super will not run, which is very important. But if you think you have what it takes and you want to overwrite everything, you don't want to call the super init, it's okay. But the super, we still call the parent class on, whereas you can still now write more custom functions in your own. It will call your own and you now call the parent class on. So that's how it works. Basically, inheritance in that. Encapsulation. Encapsulation talks about having a getter or a setter. Let me quickly just run you through what encapsulation means. Let's just say class person, and then string name. So string of name. Now here in encapsulation, you can let me just set this as is an empty string, or let me call it Afolabi. Now in encapsulation, you can use a getter and a setter to declare what the value is. Let's just say I'm using a getter now to do the name. So we are going to be string gets so automatically we've set this as get name. So we've set the name as gets. Now with this, what we do now is to set the setter. Now let's set the setter. Now in the setter here, the setter is just for you to set the name. It's not, the setter is called immediately you are calling the getter. Set name. Yeah. So what is simply happening here is, okay, when you are handling state management in Flutter, you will use this a lot. So person name, it's already, I've given him a private. Whenever in a class a variable which you declare starts with an underscore, it means it is private. It cannot be accessed from an external value. Like now, this age, it can be accessed as from outside. With my dog dots name, it's going to give me the name automatically. But once the name is underscore here, like the way it is here, even if I try to get it, I cannot see it. It will not give it to me because it's already private. Now the nice thing is, for us to now be able to access it, that's why we now use the one that is not private name. Anytime you call this thing, is getter, is going to be calling this one. So automatically now in this class, every manipulation you want to do, maybe you are trying to do this, you are trying to do that, every manipulation you want to do, you'll be doing it with this one. And this one will be what you'll be changing. And this one is not accessible from outside. But whenever they want to access it from outside, they call the name. And it's going to give you what is not accessible from outside. So that's encapsulation. We have polymorphism. Now, polymorphism is just another word for many forms. In that, your class can take up, or an object can take up different forms. And that is where inheritance comes in. there can be different forms. Now, an animal can be a dog. Another thing is, it can be a goat. It can be a goat. It can be a goat. So now we can say so it can be a goat. So it can take up different forms. It's a dog here, it's a goat here. A dog and a goat are still a type of class animal. Basically, that's what polymorphism is coming from. And you have the ability to override methods in subclasses, just like the way we've override methods here. See, it is sound now. As a goat can, even though it can just take different forms, that's simply what polymorphism means. So fine, I think we are almost coming to an end in this abstraction, which is another important concept in that. So now let's say we want to create an abstract class. Now the way we have this animal now, let me use a person as the abstract class. Okay, so for every person we want something to happen. We want to create an abstract class, so we want to call it abstract. So it's an this person is an abstract class automatically. What are the things that you think every person is supposed to do in their lifetime? Gets married, Abby. Gets married. So gets married, go to uni, go to university. So now with this abstract class I've created, now if I want to create another class that I want it to also that I want it to implement this class, it means once the class implements it, you just have to ensure that you comply with whatever standard it has. So now when it comes to abstract classes, we use the keyword implement to ensure that you inherit and conform to everything in there. So now let's go, let's say so now we can create a class boys and say what is in this class already. Let's implement person. Now it's going to give you an error here because the boy, we say boy implements person, automatically you have to implement. Let's give it a return type. Hold on. So all these functions is your class, the boys must comply with the standard that person have stated. So now we can now overwrite whatever is there. So it must conform to it, get married. So we can say print boys get married. The next one again, another thing we need to implement. So we can say boys go to university. So you see, automatically we can now call boys. We can create a class here that is called boys. var Afolabi. equals to, I'm a boy now. So immediately I can now call Afolabi dot gets married. So you can see, you see boys gets married being printed. So it's not going to call the function without the open brackets and close brackets. So boys gets married, automatically it has inherited everything here. So now, why do we use abstract classes? When you want to set a protocol in which you want certain classes to inherit compulsorily, then you can use an abstract class. For example, now you want to set up an email service and you don't want, you know that you're going to have different email service provider, and you want every new one that they are bringing in to conform to a standard that is already on ground. So you can create an abstract class and call it an email service, and then every email service provider you are using, maybe you are using different ones, and the company just decided, okay, we want to add this provider. You don't have to now start going and looking at which one did I write for this one here, which one. Once you create the class and you implement it to conform to the abstract class of the standard, you are forced to ensure that you follow the protocol that has been laid down. So abstract class is very important, and that's why I took my time to explain. So let's just quickly move to the remaining mixing, which is the final one. In our final one. So mixing, what is mixing? Mixing is, you know that in that we say we don't support, we only support single inheritance. We support single inheritance. So because of that, if you now want to use more, you want to use more classes, you want the object, the class to still have more things to work with, then that is where we come with mixins. Remember that we've said an animal ask, so we want to create a mixin. So a mixing class, we want to create a mixin. I should know the spelling is wrong. Mixing. So a mixing class, you can call it other futures. So other futures. With this, I don't even need to put a class when creating a mixing. It's already, we already know it to be a class. So now that we've created a mixing, automatically I can say when making this class, you remember I use extend, I can now use with this one. You get? Now it means even though we only support single inheritance, in that I can add as many mixins as possible. I can add 5-10 mixins, now giving us ability to mimic what other programming languages can do with multiple inheritance. Yes, yeah, in that we can just say your father can only be one, but you can have other parents. Yes, Sabi, you've inherited completely from your father, but you can still pick some minor things from every member of the family. Maybe to the uncle you pick one thing, to the auntie you pick one thing, another person you pick one thing. So basically that's how it works. So we have mixing, which can help you to pick others, extend other classes more than the actual one that you are extending. So finally, which is the last thing we'll be discussing, is interfaces. Now, by explicit, all that classes act as interface. What is interface? It's just like you extending what a particular class is, and then you can overwrite whatever it is that is in that class. And once you implement, you can implement anything. You can actually literally implement any class. It's not necessarily supposed to be you can implement any class. And once you implement, it's just like a way of extending. It's like a way of extending. So we have an assessment which I want you to look into, which is create a bank account class with the following: private balance, a constructor to set the initial balance, and then a deposit, withdraw method, and a getter for the balance. Just do this. So I will recommend you pause the video now, go to your Dartpad there, and do it. So once you are done, let me see. I also will come back and then will show you my own solution. I will just show you my own solution. Okay, so now we are back. Automatically, let me give you my own solution here. Let's call this function. Okay, this is my class. So now a bank account, a balance, and a constructor to set the balance initially. So once you are coming in, you are setting the balance immediately. But because it's a how will I call it? It's a private class, and then we need a getter. So that is where we set the getter here as balance is this. Then the function to make deposits. Now here we say if the amount is greater than 0, shall make the deposits and print it out. But if it is not, then okay, no, we can't do that. We can't deposit negative. So withdraw. If it is less, if your amount is less than 0. So what do you think? Print withdraw must be positive. We cannot withdraw negative. Else if amount is greater than the balance, no, insufficient fund. And never if it is not, then we can say, remember your conditional statements. So that's it. So now let's quickly try what I just did. Let's remove all these things, and then what's the name? What is my method here? My bank account here. My account is equal to, so the bank account is starting with 0 naira, right? There's only 0 you can have at the beginning. So now let's see my account. We are going to be making a deposit of 100 naira. Okay, the next thing again is, let me get my balance. Then let's print out my balance at this time. Print make another deposit. Let me make 0 naira deposits or minus 20 deposits. It's not going to crash. Then let me deposit another 1,000 naira. For now, let's now print my balance out. Finally, let's make a withdrawal. Let's withdraw minus 30 and see what it will tell us. And if that is not possible, then I didn't call withdraw. withdraw, not withdraw. So we're going to be withdrawing 700 naira. Then finally, let's print my balance, final balance at the end of the day. So now let's run it and see what we come to us. Automatically deposit is what? $100. You see, when we deposited 100, deposit is $100, and when we print the balance, you see. So now when we now try to deposit minus 20, say deposit must be positive, and then again when we deposit 100, it's increased again. Deposited 100, now this is my new balance. Withdraw amount must be positive, and when we try to withdraw 700, our balance is now 400. You see, that's simply how it works. And class is very important. It helps you a lot. I think with these few classes we've done, we've been able to cover all the basic principles in Dart and how we can work with it. And I believe if you stick to this channel, you subscribe, you'll become a professional. If you have questions, you can drop it in the comment section, or you can reach out to me and I will answer. And you can join in the other tutorials that we are doing. The goal is to make you better and to make you solid. Thank you very much. Meet you again in our other videos. Thank you.